Broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. I hope you're doing great. We've got the webinar tonight. If you can hear me, raise your hand. And if you can raise your hand if you can hear me. Great. And just be on the safe side, raise your hand if you can see it. You can see all these Tinker circuits. Great. So we got everybody up there. All right. We're just going to do a quick review of the LED blink and the flash, the stoplight. And then we're going to go on to some more details there. I can't see Eleanor. I don't know what to tell you because everybody else can. Do you see any kind of screen right now? Maybe she can see. Hopefully you can see it now. Can you see it now? What I'm showing on my main screen right now is a bunch of Tinker circuit stuff. We got 3 questions. Let me look at those. No, I don't see anything. Okay. All I see is loading screen. Sorry, I can see. I'm going to try. It's a good idea, Eleanor. We'll give you a moment while you restart your app. While she's doing that, I'm going to bring up the stoplight. We're going to just do a quick review of everything, what the code does. Then we're going to look at what are called PWM, and then we're going to get into some inputs. All right, while we wait for her to get here real quick. I mean, folks, let me get something. I was coughing. I just did a whole webinar with someone else. Give me 1 second. Okay, sorry for that brief introduction, but hopefully Eleanor's gotten her app back up. You can see now. Excellent. Let's look at the code of this. Let's look at the way it's designed out. If you notice, we're running 7, 8, and 9 are the pins. And think of these as these are going to provide the current. This ground is shared across all these 300 ohm resistors. So if we turn that pin on, it's going to go here. That's going to be positive, ground back. It can complete a circuit. And therefore, that light will come on. So let's do this. On Tinker Can Code, I cannot click and drag anything. What did I do wrong? Make sure you turned off the simulation. Will we be using any new components? Yes. So if you start the simulation, my guess is you show code. Not sure it can. Well, mine's working there. I'm not sure why there's not that other than restart it. Right, and then I find sometimes though you can't touch things in here. Once you start the simulation, you can identify things, but you really can't change them. So what's happening here, so let's look at our code. When we start, pin 9 is high. That's the red one. The other two are low. Then see how that's high? These two are low. Yellow's high, then green. The other two are low. So we're using our software to go ahead and change these. Okay. Any questions on the code right here? For 4, we turn on pin 9 to high. The other two for low, we wait 4 seconds. That gives you the red light. We go turn on 9 low. That turns off the red one, but it turns on the yellow one. And the green one we turn off, so only the yellow one's on. We wait a second. Then we turn off pin 9 and 8 that's connected to both the red and the yellow. Turn on green high and do that for 3 seconds. 3 plus 1 equals 4, and it adds up there. Any questions on that? All right, now we're going to stop that, start the simulation. We're going to add something here. All right. Okay, let's pull that up. Let's go ahead. Let's hide the code there. We're going to search. Okay. And what we're going to search for is we are going to look at an example. All right. You can use PWM for things and servos and whatnot. So we could hook up a servo and control it with that. That's why they say the pulse, but we can also hook up another LED. So we're going to take another LED. All right. I'll pull out the code. In fact, we're going to use another LED and we're going to make things light and bright and dark. So I'll tell you what, even before we pull out the LED, let's make a copy of this. That was a little bit more than I want to do. Go to circuits. It says tinker that, or you can also duplicate it. I'm going to duplicate it right now just so I can speed things up. Get everything hooked up. I invite you to do the same thing for just what we're doing now. I want to show you something else we can do with this. We're going to delete this one. Now, actually what we'll do, we're going to move these things. If I can get to the end of this. Yeah, if you can zoom in, which I hate when this happens. On a Mac, it doesn't play, like, no matter which way I'm turning this wheel back, it's zooming farther out. Let me go back and I'm bringing this back up. Tinker this. Hopefully it'll show up. If it doesn't, if it's really tiny, I'll make another duplicate. Come on up. There we go. Let's try not to do it again. All right, when I click on this, see when that little, if it changes that circle, I can pull this out. If you don't, it won't add another wire. But I'm going to go 12, and then I'm going to take this 8. And again, click on this once, go by the end, move that to 10. Then I'm going to take green. Now, and just show you, we're not going to do it with 8. We're going to go back down to 6. We're going to drop in another LED. And we make this, I don't care what color you make it. Let's see here, I can go to red. We can do white, like that. Here's white. We hit R to rotate it. I'm just doing this for consistency's sake, folks. Then I'm going to add a resistor, rotate it, make it 330 ohm. All right, pull that on the ground. It's sharing the ground with those, but we're going to go from this pin here. This is different than what we've been doing. Now, we're going to do this be white, but that's going to be a little bit hard to see. All right, so there's white, red, green, and white right there. And maybe that's a really dumb idea on my part, so let's do this. We're going to change that color to pink so you can see it. I don't know, what about our LED resistor here? White, do we have a pink? Nope, we're just going to leave it white, but we're going to use red so you can see over that. All right, now we're going to do a little bit of different code here. This is called PWM. PWM, let's go ahead and take a look at this now. We use it for servos, we do different things. So I'm going to actually pull some code from a servo. Let me see here. We look at our examples. So one thing you can be doing, go under examples, here's breadboard, blink. Don't be afraid to look at examples and say, well, how would I make that example? And then you can always go back and check on it. So what we're going to look at here is there's a fade here. And we're going to go ahead. I can even bring this code up here. There it is. So mine is going really good. Old Mac here is just having a bad day. I'm waiting for it to stop moving, so we move it around. Tell you what, delete. Say, okay. All right. Before you delete it, it's saying, hey, you're reducing a bunch of code. Let's see if we have any code left. Let me get rid of this. In fact, let me dump that. Let's try this again. Let's put all this on, select this. I'm going to delete all these blocks. Remember, I've made a copy of the stoplight, so I'm deleting these blocks. I don't know why the trash can didn't want to work, but we're going to just delete blocks. All right. Let me hide the code. Let's try to bring one of these over here one more time. Oh no, of course, immediately did it when I didn't want it. Okay. Here's what I want is fade. That's the one I want. All right. All right. So I'm going to go down here to fade. I'm looking at the code here. Count up by 5 for brightness from 0 to 255. Switch pin to brightness. Count down by 5 for brightness from 255 to 0. Set pin to brightness. This is allowing you to do a variable, which we can then do PWM. So what I mean by PWM is when you're exposed, that LED is on for just a moment, it's going to look lighter than if it was on for the whole cycle. What you need to do is a computer runs a 60 megahertz cycle, and all that is just think of a time. And when it's on digital, it's on the entire time. But when it's PWM, you know it's PWM because these little slashes, it's on just part of that cycle. And so watch what we're going to do here. We're going to take that bit of code here, title button, fade in. The example shows fade in, but look at the code here. Count up by 5 for brightness. It's a variable. And then we're going to set pin 9 to vary. So there's your variable, right? So that's what we're doing. So let's go ahead and do our own. So we're going to get rid of this one. Get rid of code so I can delete this. It's going to delete this code, no? Hopefully I can say, okay, I got rid of that. So now I'm going to go to code. All right, So we are going to, first of all, we have some variables. Create a variable, we'll call it brightness. Say okay. All right. Then we're going to go into control. And we are going to do count up. And we're going to start this is a new change that we're using variables. And we're going to count up by 5. From 0, let me move this over so everybody can see this. Oh, man. Great. I don't know why it's not letting me do this. I want to see it. If I could show you, what it's going to do, it's going to count from 0 to 255, because that actually ends up being 256. And so that's the highest end of this is 255. All right. Then we're going to go to output, which is in blue. All right. You got rotate, turn speaker, print serial, set RGB pins. That's for changing that. All right. So we're going to set pin. All right. Now that's when it's going to be totally digital. We don't want that if it's high or low. We want to set it to a value. And notice now it doesn't allow all those. It just allows the ones we want to do. So the first one we're going to do is 6, just to demonstrate to it. And instead of just being a number, we're going to put brightness there. We're going to go to the variable, grab brightness, and put it in there. All right. Now I'm going to hide the code. Let's watch what this when we start the simulation. See how it's. I, of course, probably picked the worst one, but it's getting brighter. It got totally brighter. Let's stop the simulation. And you can make the whole thing look like it's sleeping and stuff. So let me go back over to code. Instead of going by... We go over here again. Okay, I'm bringing this. Count up by 5. We're going to this time count up by 2. So it goes a little bit slower. 0 to 255. Set pin 6 to brightness. We're going to add another pin. We're going to do set. Again, that's the starting at a number. It's going to be brightness as well. Say I want to turn that green one on. What would the pin number be, folks? Once you think about it, what pin would I use? All right. I hope you said pin, that's hooked up to 9. So we're going to go to 9. There it is. Now watch when we watch the simulation. Watch what the white and green one do. They're slowly getting brighter. They start off, and we can even make it wait a second and do this. We can do control. We can say wait 2 seconds once it's totally bright. And then we can do a reverse. We can do a countdown. Same thing. So we're gonna count down by 2 from 255 because we're going to reverse order. I'll pull this over so you can see it. Oh no! Oh man! Can't believe I just did that. Oh, let me see if I can get it back. Don't know if I can get it back. I will try. No. This is doing the same content. I'm going to use their code, but that all it did was replace what I just lost. Shoot. I'm not really crazy about how they do this code on this. All right, let's try this again. I'm going to just go really fast. We're going to repeat. We're going to do count. Well, actually, we can do it this way. What do I have? Count. Let me see my variables. Brightness. Count up. brightness. There it is. From 1 to 10, we're going to go from 0 to 255. All right, and we'll make it 2. So it'll go up and we'll go too fast. And then what we're going to do is say output, set pin to brightness. So it's going to start at from 2 for brightness from 0 to 255. So we'll I'd set pin. Are we connected to pin 3? No. So we need to make that pin 6. Right click on this, duplicate it. We're going to make the pin 9. I'm going to duplicate it. Pin 10. See how the little dash is? That's what we're trying to do. And then right click. Pin 11. Now, every time we do this, it's saying in there, because the nature of the simulator, to wait it to slow down a little bit. So let's slow this down to 0.2 as it's doing this. All right, let's go ahead and run this. These are slowly getting brighter. All right, stop simulation. Start it again, watch. It'll slowly get brighter and brighter. On real LEDs, it looks a lot cooler, I'll be honest with you. All right, let me see what questions people have. Well, that's not what we want. Sorry about that. Let's pull it up over here. Okay, any questions? Would it be best to make a few properties just in case? You bet. Can you please tab the full screen? I can't view personally on my device. Well, the problem with that is me doing full screen, I start getting trouble going back and forth. I'll do what I can, but I'm pretty full screen. I am recording it. All right, I'll show you the code. There it is. So it's bringing it up, and just put down the questions there. It's slowly increasing. Now, if I want to, if I can do this without, I'm going to move this over here. I'm going to pull this out. Oh, boy. I'm trying to go. This is full screen as I can get, guys. We wait 2 seconds. It goes all the way through and does that whole loop. Now, what I'm going to do is add another loop. This time, which I was trying to do before, and it went down, we're going to count down by 2. And we're going to use brightness again. And we're going to start it from 255. Now, this is where I got to be really careful. I almost dissolved the whole thing last time. 0. So we're going to start at the top, and we're going to count down from 255 to 0. And we're going to do the same thing we did before. I'm going to take all these and copy it. Now watch when can you predict what it's going to do? I'm going to hide the code or a little bit. Let's look at the code again. It got brighter, way to 2/10, and then look at what it's doing. So let's watch the simulation. See if you can. One really good thing is to watch what it's doing. And I'm going to have to jump it by 5 just so we can see a little bit faster. I don't know if you can see it on your screen, but what it should be doing, it gets bright and it should be fading back down. So what I'll do is I'm going to code this. I'm going to speed things up. I'm going to do by 5 here and by 5 here. Let's try it now. And then what it'll do is it should get brighter, and then over time it should dim back down. And it's dimming back down. Now it's dimming back up. And then in a minute, you'll see it start to dim back down. And we can use that PWM to allow you to do a lot of finer controls, to make something almost like digital analog when it's deep down inside digital. And we're going to do another one. So this is going to I'm going to rename this. I'm going to say light LED fade. I'll save it later. So if I want to look at it, I'm going to go back. I'm going to go in here, go back into Tinkercad. I might do a new one. Go back here. Create a new circuit. Was there any questions on that one? Kind of going pushing ahead here, but what's the variable determining? What's the variable determining? The variable is just being a counter. All you're doing is increasing that brightness by 0.2 every time. All right? That's all we're trying to do as a counter there, all right? It says 2 seconds. Well, that delay is just so the LEDs, so the simulators can stay up. It's going on to cloud. You need to slow the actual process up. Apparently, in the past, there was a problem with Tinker Circuit. That's just for the simulator. All right, so now I'm going to go over here, and let's look at PWM as I practice for this. I'm going to go over here to Basics, Arduino, and we can do a button a little bit later, but right now we're going to do, what am I pulling this up for? I just did, a servo. So let me do another output, and then we're going to stop here. Let me pull the servo out. Now remember, in a servo, you need to hook it on a breadboard. So let me see if I can, great. Okay, so what do I mean by doing this on a breadboard? Well, see, you've got 5 volts going to the middle one, ground is going to this one, and then pin 9 is on the outside. So let's just do it this way. What I'm going to do is I'm going to go basic. I'm going to find myself a little servo like that. If I have to, I'll type in servo. This is how I would do it. So there's a little micro servo. Put that right there. Okay. Then I'd give myself a breadboard, because I know he's going to make me do this. And I'm going to go breadboard. Let me see what kind of breadboard. Where's a small breadboard? There we go. Drop that in there. And what I'm going to do on my breadboard, remember we clicked on this before? I'm going to grab the end of this. I'm going to put it right over here like on my breadboard would be. See the end of this one? I almost had it. Grab the end of that and put it over on the red one. Then I'm going to take my servo and I'm going to connect, because I know I got a breadboard. I say, oh, this left one's got to go to the ground. So this one has to go to ground. So I'm going to take this. I'm going to make it ground black so I remember what I'm doing there. Now I'm going to take this red one, which is in the middle, according to that deal. I'm going to make it red. And then finally, you have a signal from pin 9. Well, now that I've pretty much got this, I can just go grab this one. You know what, though? Let me hang on one second. I'm going to do this. I'm going to move this one out so I can, and then I'm going to put the signal so we can see it. Now, if I start a simulation, see if it's doing anything. Other than that, I have to go lucky there. Let's see what the code looks like. Sweeps from 0 to 1, same thing. Tells her the variable position. It's going to increase it by 9, wait 15 seconds, do it again. For some reason, I've done something goofy. Let's stop back. My guess is this isn't connected to one of these. Okay, I'm going to do that. Is this one connected there? Now I have a ground here or what? No. I'll tell you what, we're going to move it on this one just to see why these aren't working here and then figure out, okay, what is going on? Oh, I know. Oh, guys, what a goofy thing they've done. All right, so here's what we're going to do. It's going to go here. All right, but what we needed to do is take the 5 volts. I'm deleting these off now because I know where they've got to go. That's all I was trying to do originally, line them up. But once I do that, I've got to get the... All right, so 9's going to this one. 5 volts is going to this one. Middle. And then the ground, I'm going to put right over there. Make that black. All right. Let's try it. Okay, it's still acting a little bit funky. Let's stop the simulation. I'll put that there. Then we'll run a wire from here to here. Let's try it now. There it is. It's working. So these connected right onto here. There's here. This is. We want to use a breadboard to make sure that it's working. And so let's look at our code. All right. So I'm going to stop simulation. I'm going to look at the code. Again, another loop. There's a comment up here. Sweep the servo from 0 to 180 degrees. Count up by 1 for position. That's the position of the servo from 0 to 180. So it says rotate pin 9. That's why we're here. To position. That's 1. That's why it's doing that. It's going to 1, 2, 3, 4. This is counting all the way up to 180. Pausing and then going from 180, count down from 0, and that's why it goes back. So watch the simulation. All right. And notation here. There's our comments so we can write about everything else. Can I do this? I want to see one other thing here. I was hoping I would have. No. Okay. Unless it'll, all right. Serial monitor. That's what I'm trying to pull this up to look at. Let's see if it'll allow me to do it with this. I don't see a block for the serial monitor here. And I thought, well, maybe it'll just print any variable that's coming, but it's not. Let's see here, map, pick random, absolute value, constraint high, nope. Control, let's see if it's in here. No, we can do it as a text block. I've done it. All right, here we go, print the serial. This is what I want to do. While this is rotating around, we're gonna print this out with, we're gonna put in position. We're gonna go to variable, and you're gonna put it in position there. All right. Now watch it when it goes up. We're going to do it right to pin to that. Again, we're going to go find blue, print the serial monitor. It's going to be position. The variables, position. Put it right instead of hello world. Now when we run the program, we should see our serial monitors. The value is going all the way up to 180, then back down. Go ahead and see if you can do that. That's a good way to make sure you understand what you're doing there. I want to do output. These are all outputs. We're going to start doing some inputs in a minute. All right. Now, any questions on that? I'm looking under questions, guys. We get that. All right. You need to construct power and ground. Thank you, Ben. Which Arduino board is this? Arduino Uno. What's the purpose of the comment blocks? Just to tell you what you're doing so you remember. My serial monitor numbers are going. Let me see if I can get this to show up. Let me switch out a little bit. My serial numbers is going backwards. I bet you're counting down as opposed to counting up. It'll go up and it'll go back down. It's sweeping back and forth because if you look at your code, look at my pointer here. Here it is. 1 going from 0 to 180. Here it's going from 180 back down. All right. Does that all make sense, folks? All right, here we go. Okay, let me look up at this and see. Do the comment affects the actual code? No, but they help you remember what you did. Is there a suggestion of a list of circuit components that students need? It'll be all the basics. Just do the basics, guys. We're not going to get into on this. The basic components for Arduino. Use those examples would be what I would tell you. So I'm going to go ahead and go to the next one if you don't mind. So I'm going to go back here. I'm going to do another. I'm going to go back to Tinker Circuit and let's do an output. Now I'm going to do another one. All right, here we go. Okay, so now let's go again. We've all been doing outputs. Let's do an input. I'm going to pull up Arduino and I'm going to do a button. All right, and you can do a button. You can do analog input, digital read serial. Okay, let's go ahead and button. I really don't like how they do this where they don't use a breadboard. All right, I really am not crazy about this because in real life, you're not hooking that up without a breadboard. I know they don't like doing it because people can't see the breadboard. I understand why they're teaching it, but we're going to talk about this in a minute. First, right here, that is a, if I can pull it up, and of course not. This is a 10K resistor. We're going to bring in a breadboard. Let's search and do it the way I would do it. Hopefully I can get a breadboard small. Let's see what we can get here. This is going to be a digital one, breadboard. Let's not go into Arduinos. Let's go all so we get breadboard here. We want a small one. There they are. So let's do breadboard small. Okay, great. Now, again, we can sit and do some of this just like they have it, and you can run it right over here. So what we're going to do is go over here to the button. All right, so I'm going to take this button. I'm going to even put it across here so I know it's going to work. All right, so in this button, I'm going to go ahead and put on this side a 10K resistor. All right, and I'm going to explain why here in a minute. And we're making that 10. So it's a 10K. All right, so that's a 10 Krabby resistor. And on this side, I'm going to take a line from the 5 volts ultimately to right here. So that's my mouse going down a little bit here. So I have 10K going to this terminal, going to the ground. This is going to go to the red. In a minute, we're going to pull it all in our Arduino. And then I'm going to take another line here. I'm going to use 8. I could actually use any of these. All right. But we're going to use 8. We'll change the code to reflect what we're going to do. I'm going to take this, connect it to the red here. Take this. All right. So I'll let ground to work. Let me go click on this second. Make this black. All right. We're trying to make a ground here. And we could have just deleted the whole thing. And I'm about to the point to do just that. Delete, delete, deleting this all out. Then I'm running the ground to here. There's 2 grounds. I'm making that black. So let's watch this current when this runs through. When this is turned on, this current's going to go down here, go to that resistor, that's the ground. So if the power is going to the 5 volts, it goes up to the button, goes to that leg, goes down. So that way there's a cycle. But say I press that button. Well, now it could either go to this side or this side. This side has a lot of resistance. This side has a lot less resistance. So the full 5 volts are going to go up to here. Where on this side, because there's that high of resistance, you don't want, like, say, 2.5 volts going up here, because then you don't know 2.5 going to the ground. This has no way of knowing, is that a full? So you want a high signal. And the way we do that is we make sure we go to complete. When I press this button down, let's watch. I don't know what's, okay, what's going on? It's usually, here we go. Digital input. Oh, I know, only the code. Well, I need to change the code for it to work. What the heck? Yeah, there we go. Let me go back in here. I'm going to go back and bring it back. All right, tinker this. I'll bring it back up. Whenever my mouse does it, I just find it faster for me to do that. All right. When this plugs in, let's make sure I'm getting a ground here. So that ground's going in there. This is ground here. This red's here. The button's going to go when I press it, but nothing's really going to happen if I press that button. So let's look at our code. All right. button on and off depending on what that is. Now this is driving me seriously to distraction the way this comes over here. Read the state of button value. Set button to rigid, set push button 2 to read digital pin 2. If button stayed equal to or higher than high, turn LED on. Set LED to high. That's the built-in LED. So that's going to be this LED right there where my point is. Else this. Now, what pin are we talking about though? Set button state to read digital pin 2. We're going to read digital pin 8. Now let's start simulation. All right, so it's on. See the LED? It's on now. When I don't press the LED, off. Press the LED, it's on. What's going on here? The reason we put this resistor is we want all the voltage to go over to here to 8. Otherwise, it would have a choice. You would go back to that ground, or it could go to here. This way we prevent it from going there. And that's what this if statement is saying. Hey, if it's equal to, this is equal to high, turn the LED on. Else, turn LED low. So that's what we're doing right now. So let's go ahead, press the button. You can see the LED. This is why we have this little LED, so we don't always have to hook it up. So that all makes sense. All right. We now have that. The common code too. What will we do next webinar? See how far we get on this webinar. Are the basic team will listen on basic does it? Oh, let me see here. I can't. Tim, I don't know what you're saying. For some reason, this is not going to let me blow it up here a little bit better. Let me pull this up. I don't want everybody else. What we do next webinar, we'll do maybe more outputs. Are the basic Tinkercad or listen on basic and Tinkercad, or does it? I don't. Tim, I'm out as long as this is. So Tim, you're going to need to write another part of this. What is the red switch on Arduino's left top hand corner? That's a reset button. This is a reset button. Tim, you had another question there, but you wrote too long. Can you break your question in a couple parts? So now this is called digital read. And we can actually show it with our serial monitor again. I can't stress enough using serial monitors is important. So it says set to high. We're going to do an output. Print serial monitor. All right. And we can say you pressed, I would type you pressed the button. And then I would say, next one, let's go print to serial monitor. You're not pressing. All right, so then we do that. Let's start the program. If I look at my serial monitor down here, you're not pressing, you're not pressing. Press the button. You press the button, you press the button. That's a great way. The LED is a good indicator, but also a serial monitor if you actually need a value. That makes sense, everybody? All right, you're making Tim. You just copied the same thing. Send me, are the components going to be used under the basic component list? Stop there. I've got that. Give me another line that has all of it in there, because I can't read what's after it. Are the basic components, are the components we're going to use under basic, for the most part, and they're going to be basic and those ones found with Arduinos? Yes. All right. So now next one, stop simulation. So I've got digital input. I'm going to go back here. And then I'm going to do, so I'm doing a new one. I'm doing this way so it's fast to cover a lot of ground. In class, I would probably do it a little bit differently. This will work. Let's go to Arduinos again. Blink, button, fade, debounce. Well, let's go over here. Let's look at analog input. If digital was on and off, analog is a range, like how cold it's outside, how dark is it in a room. It's a range. So let me pull this out here. So 5 volts ground, A sub 0. And what that does is, let's look at their code. Read the value from the sensor, turn the LED on to high. Stop the program for sensor value in milliseconds, wait in milliseconds, turn the LED off, set to low. This is going to change how often you can turn things on and off. Again, I'm very much into understanding what's going on. Oh, see, I got to make a copy, but it does not want me. Well, no, it should allow me to do that. What the heck? I'm going to add a serial monitor. Set sensor value to analog, and it's just going to say wait sensor value in milliseconds. Wait the sensor value equals milliseconds. So what it's doing is the more watch, I'll run the program for you. So see that LED? If I grab this, see it'll blink faster or slower depending on what I do. See how quick that is? In this case, look how slow it becomes. Now, let's stop the simulation, look at the code. So that read analog E0, that's what I'm going to start printing out here. So I'm going to go to print the serial monitor. When it's high, I'm going to say that's analog. All right, so we're going to read, and that's going to give me the analog value. And if I copy that, why did I just hit delete? Oh my goodness gracious, Tom. Oh man, this really could do with it. All right, let me see here. So what I'll do is, let's try that again. I'll put print the serial monitor. We're going to sit there. When that's going on, we're going to say, hey, let's make that sensor value. Then I'm going to do that again. Let's try duplicate. I want to duplicate all that. All I want to do is we'll just do output. It's going to be faster away, apparently. All right. Print serial monitor again down here when you set it to low. And we're going to use sensor value as our input. Now watch when we run this program. Get down here. Hopefully we can. Our serial monitor on this. It should have it. Let's try. Oh my goodness gracious. Oh my goodness gracious. Page down. Let me see. There's a serial monitor. Let's bring it up. Hello world. Hello world. It's going back and forth on it and in the analog. Let me play with that a little bit here. Watch this. It's going to be one or the other, no? 962. Let's, and oh, I know why, because it's going back and forth on this. Let me do this. And instead of saying, wait, sensor value, Let's go 9. Read analog pin. Oh, print. Let's just get sensor value over here. So what we're going to do is get the values. Sometimes it pops. That's when the pause isn't there. Oh, we have this on here for some reason. Let's delete that. See? And if we change this, which I've gone and deleted that out, but if you were to change the potentiometer, those numbers would change on there. Yeah, that came off. All right, folks. So I've showed you a strategy for looking at examples on the Arduino, looking at the code. We've looked at digital input. We've looked at analog input. We've looked at digital output and analog output. That goes a long way, folks, what you need to know. We have another lab Thursday, and that'll be more of an answer question lab. I think we've gotten enough to go ahead and just try that. I'll give you a minute here. Does anybody have any questions? Let's go. When will you post the webinars? I posted the other ones recently, and let you know that then I'll post this tomorrow, and I will make sure it goes out to everybody. Since we have more people sign up since the original time, I'll go through and make sure I have everybody on the sign up. All right. Okay, folks. Thank you all for being good listeners. If there's no more questions, I'm going to go ahead and call it a night on this. Okay? This will get posted by tomorrow night. Give me 24 hours, please. All right. Take care, everybody. Bye-bye. You're welcome, everyone. Bye-bye.